Although you may not notice it, you are currently moving at great speed through space and in various directions. The movement around the Earth, the solar system, the Milky Way, even our own expanding universe, are just some directions of speed and on different scales. Which makes us wonder, would it be possible to stop completely, canceling all speeds and being at absolute rest? You may find this point of view disconcerting. Well, we have always asked ourselves, what would happen if the Earth stopped? What happens when you reach the speed of light? Or if the sun disappeared? But we almost never ask ourselves what happens when we stop all the movements to which we are subjected. To calculate a speed, we always need a reference system. If you drive your car at 100 kilometers per hour, you are moving at that speed, but with respect to the ground. If you move through the cars of a train, we will see two directions of speed. On the one hand, the train is going at 120 kilometers per hour with respect to the Earth, but you are moving inside it with respect to the train at 5 kilometers per hour. This is the case with all objects in the universe. There is no absolute speed. It is not possible to list all velocity directions individually, since there are countless objects in the universe, each with its own relative velocity. If we removed all the velocities of the Earth and its orbit through the galaxy, we would always find another object that is moving with respect to us. For example, a galactic cluster. However, we can imagine what would happen when all these speed directions were cancelled. Galileo Galilei had formulated the laws of motion in the 17th century, which are valid for speeds much less than the speed of light. These laws, known as Galileo's laws of motion, describe how moving objects behave relative to an observer at rest. They are an excellent approximation for most everyday situations at low ground speeds. Relative velocity directions, however, were described and understood primarily through the contributions of Albert Einstein in his theory of special relativity, which was published in 1905. This theory fundamentally changed our understanding of how the laws of physics work in the context of objects moving at speeds close to the speed of light. Movement is relative and depends on the observer. Because we do not notice constant velocities, for a long time, it was thought that the Earth did not move and was also flat. For someone who doesn't think much, it is easy to deduce that everything comes down to what we observe and notice. But we are so small that we are subject to many optical illusions. Even Einstein with his theory of relativity still thought that the universe was static and had always existed. The only thing I knew in space was the solar system, nothing more. Edwin Hubble demonstrated that the universe was expanding and that made the galaxies move. With the development of cosmology, we also discovered that we were in a galaxy cluster that moves with respect to others, because the universe is dynamic. Everything moves in the cosmos, nothing is at absolute rest. Hubble's discovery gave way to understanding the existence of active electromagnetic fields that are in space. These fields had already been predicted by Maxwell in 1864 and corroborated by Hertz in 1888. Absolute rest and the speed of light have many similarities. The speed of light is the maximum that any body can reach with respect to space-time. No object with mass can reach the speed of light, since according to relativistic equations, we would need infinite energy to continue accelerating it. In several videos I have told you about its surprising effects, one of which is the absence of time and the compression of the universe. But by stopping all the movements of energy and matter, the effects are even more surprising. So what would happen if we tried to slow down all the speeds we are subjected to in our universe? In theory, it is possible to stop all directions of velocity for a body, but this would require an infinite amount of energy and is not practically feasible due to the fundamental laws of physics. In accordance with the principle of conservation of momentum, linear momentum, which is a fundamental law of physics, a body in motion will continue to move unless an external force acts on it. This means that in the vacuum of space without any external force acting on a body, its speed will not change and will remain constant. To completely stop all directions of speed of a body, you would need to apply an equal and opposite force in each direction of motion. So the net velocity has been reduced to zero. However, this would require an infinite amount of energy to counteract all possible velocity directions, which is physically impossible. There will always be some residual velocity due to factors such as temperature, cosmic radiation, and subatomic particles interacting with the body. But suppose that a person stops all his movements and remains in a state of rest in relation to the universe. In this experiment, we will cancel out gravity and all the directions in which we move. To understand it, we will gradually cancel the direction of the Earth's rotation and around the Sun. Then he would look like this poor unfortunate. He would move away from the Earth and contemplate how everything around him moves in various directions. By canceling the movements of the galaxy and others like the galactics, we would contemplate a chaos of movement. The static universe that Einstein imagined has become a celestial dance where everything dances to a frenetic rhythm. Stars moving in a circle in their galaxy, planets around their star, galactic clusters through other galaxies. But there would come a time when, by canceling all the velocity vectors, we would see a static universe. We do not move with respect to anything. This frame of reference is impossible in physics. But as a thought experiment, it is surprising. From the theoretical perspective of a static observer in the universe, one could say that all movements are illusions, in the sense that cosmic objects and phenomena would not experience changes in position or speed in relation to that observer. However, when we move again with respect to the cosmos, everything also begins to move. Are we moving, or are it the other objects? We have seen that to stop movement requires infinite energy and is impossible in practice. However, as static observers, we have only achieved a state of rest, but not absolute rest. Despite our impossible, static frame of reference, our atoms and subatomic particles are a perpetual dance of charged motion, spinning and vibrating. What would happen if we reached a state of absolute rest and made everything stop? The movement produces heat, and logic tells us that the solution is to lower the temperature to -273.15 degrees Celsius. It is the temperature of absolute zero, the lowest possible, at least theoretically. No body has been able to reach such a low temperature. At absolute zero, particles have the lowest possible kinetic energy according to classical physics. Scientists at the University of Bremen achieved the lowest temperature ever achieved, reaching -273.10 degrees Celsius, thanks to a quantum process that slowed down a cloud of atoms. But even at absolute zero, it is impossible to stop everything. Subatomic activity. Particles are not macroscopic objects, nor balls, but due to their wave property, they are excitations of quantum fields that have a certain amount of movement and vibration, even at low temperatures, which is their nature. If there were no vibration, they would not exist. The Heisenberg uncertainty principle tells us that there is a certain amount of kinetic energy due to this inherent uncertainty. In other words, there is always a quantum fluctuation in the speed and position of the particles, at extremely low temperatures. But when we stop subatomic motion, we lack the quantum vacuum. Zero-point energy cannot be eliminated. It is like the source code or program of the universe, which is full of quantum fluctuations, which provide a minimum amount of energy, even achieving absolute zero. Why does the universe put so many obstacles and prohibitions on us to stop all movement? Now we will see why. We're going to violate every known rule of the universe in this thought experiment, and see what happens. This brings us to a truly terrifying paradox. If we were observers and could eliminate all quantum activity, on the one hand, time would stop, and on the other we would disintegrate. Not even Superman could stand it. According to the theory of special relativity, time passes differently for observers in relative motion. So without movement, there is no time at all. No change event would be perceptible. It would be as if the universe were frozen from our point of view. Without information, we would be immersed in true death, nothingness. There is no information, nothing happens, but the worst of all is that a chain reaction would immediately start that would end up collapsing the universe. A gigantic black hole. Nothingness would end up swallowing the universe. In our tireless quest to understand the vast canvas of the cosmos, we have arrived at a fundamental revelation. In the universe, nothing can remain motionless. Each system, each entity, is intrinsically dependent on the eternal dance of movements that surround it, as if they were the interconnected parts of a living organism. This entire vast universe must be kept in constant motion so that information flows and existence itself persists. We can see it as an immense network of connections, a cosmic fabric that is intertwined in a perpetual ballet. In this endless dance, we find the very essence of eternity. The birth of our universe can be understood as a response to this inherent need for movement and change. Since time immemorial, it has been a constantly bubbling entity, a fiery furnace where matter and energy are transformed incessantly. Even as we contemplate the distant possibility of the heat death of the cosmos, we recognize that this transformation will never completely stop. The universe, like a master craftsman, continues to shape and sculpt its elements, ensuring that the spark of life and information endures. Both the speed of light and absolute stillness are extreme limits that are impossible to achieve in practice, but they give us a fascinating new perspective on reality.